Okay, so if we're given this function and the objective is to find f inverse prime of a, which in this case is 11, using our theorem. We've got our theorem spelled out. We know a is 11, so let's go ahead and plug 11 in. We've got g prime of 11 equals 1 over f prime of g of 11. Now remember, g stands for the inverse of this function. We're just using that to make the notation a little simpler. So if g stands for the inverse of the function, and we're trying to find the inverse prime of a, what we got to do is evaluate this side. To evaluate this side, we got a little composite function right here, where if we start on the inside and we work our way out, it would be nice to know what g of 11 is. Now again, g connects to the inverse, but I'd like to be able to do this without actually finding what the inverse is. So off to the side, since I want to find g of 11 first, let's do this. This is where I'm going to set up my work to figure out what g of 11 is. A simple way to do this, knowing with inverses that the x's and the y's are just kind of switching their roles based on how they're defined up here in the original function. Easy way to do this is to take the original function as it is, this 36 minus x squared, and set it equal to this value you're plugging in. I mean, if the x's and the y's are switching, then this value of 11, that goes with that y idea for the original function. If you solve this for x, so if I solve this for x, I might add my x squared over here, subtract my 11 over here. If I subtract my 11 over here, I've got 25. Taking the square root of both sides, x would be, normally I'd say plus or minus 5, but here I can say 5 because I know x's have to be greater than or equal to 0. So if x is 5, this 5 can go in that position for g of 11. And if I rewrite now what g prime of 11 equals, knowing g of 11 is 5, I've got 1 over f prime of 5. If what I'm trying to find here, g prime of 11 equals 1 over f prime of 5, then it would be really nice to know what f prime of 5 is. So off to the side here, I could set up f prime of 5, figure out what that is, and reinsert that answer over here. So let's see, f prime of 5. To find f prime of 5, I need to know what f prime of x is. If this is my original function, it's not too hard on this one to figure out what f prime of x is. F prime of x is just going to be, let's see, 36 minus x squared is going to be negative 2x, right? So, if I'm trying to find f prime of 5, plug in 5, negative 2 times 5, get negative 10. So f prime of 5 is negative 10. Take negative 10, substitute in. We find that g prime of 11 is equal to 1 over negative 10.